Hello everyone, I'm Xuehai He, a master's student from the University of California, San Diego. Today I'm going to talk about our work, PathVQA, the first step towards an AI pathologist. Before moving on, let me first ask a very interesting question. Is it possible to develop an AI pathologist to pass a board-certified examination of American Board of Pathology? Well, pathology studies the causes and effects of disease and injuries. To become a board-certificated pathologist in the US, a medical professional needs to pass a certification examination organized by the American Board of Pathology, which is a very challenging task. Among the examination questions, one major type is to understand the pathology images. Given a pathology image and a question, the examinees are asked to select a correct answer from them. These figures show some examples. To train an AI system to pass this exam, the first step for us is to collect a dataset containing questions similar to those questions in the ABP test. And let me show you some examples of questions in our pathology VQA dataset. Our dataset consists of more than 30,000 question-answer pairs generated from pathology images collected from 2 pathology textbooks and online digital libraries. As you can see, these questions are very similar to those questions seen in the ABP test. And here is the collection process of our dataset. It mainly consists of 2 steps. The first step is to extract pathology images and their captions from electronic pathology textbooks and online digital libraries. Another step is to generate question-answer pairs from captions. And this is the overall framework of our question-answer pairs generation from image captions. At first, we get the captions from the textbooks and the online digital libraries. And then we do simplification on those captions to generate simple sentences. And we build a question transducer to extract questions and answer phrases from those simple sentences. And we do a final post-processing on those questions and answer phrases to obtain our question-answer pairs in our dataset. Here are some examples of each type of questions in our dataset and their original sentences that we use to generate those questions. Our dataset finally contains open-ended questions belonging to types of what, where, when, whose, how much, how many, and yes/no questions. This table shows the number of questions and the percentage of each category in our dataset. And we evaluate 3 well-known baseline methods on the PathVQA dataset. All these methods use the attention mechanism to infer the answer. And we used 3 evaluation matrices to evaluate those 3 baseline methods. The first one is the accuracy or exact match for yes or no questions or open-ended questions respectively. The second one is the F1 score, and the third one is the blue. And here are performance on yes or no and open-ended questions in our dataset, respectively. Thank you for your listening.